Hello everyone. In this lesson, we will learn about the next key process in chlorine treatment, chlorine drying. Chlorine drying mainly includes three aspects: the principle, process, and equipment of chlorine drying. First, we will learn the principle of chlorine drying. The principle of chlorine drying is generally that the water in the chlorine is absorbed by sulfuric acid after it comes into contact with the wet chlorine. The equation for the rate of water absorption by sulfuric acid is as follows. As you can see, the water absorption of sulfuric acid is related to the absorption area and the saturated vapor pressure. There are two most common chlorine drying processes. One is the 2-in-1 tower process with packing and sieve plates, and the other is a two-stage drying process, consisting of a primary pack tower and a secondary composite tower with packing and bubble caps, chlorine packing, and sieve plate 2-in-1 tower drying process. After drying, the chlorine contains about 300 ppm of water, which can meet the water content requirements of chlorine compression using a Nash pump. Two-stage drying process composed of a primary chlorine packed tower and a secondary composite tower with packing and bubble caps. After drying, the chlorine water content is boundary 100 ppm, which can meet the water content requirements of chlorine compression using a centrifugal compressor, i.e. small turbine. The following mainly focuses on the first process flow for detailed introduction. This diagram is a simplified flowchart of the chlorine packing and sieve plate 2-in-1 tower drying process. As shown in the diagram, the wet chlorine from the water mist collector enters from the lower part of the packing layer at the bottom of the 2-in-1 drying tower with packing and sieve plates, and flows upwards through the packing section and sieve plate section in the tower, fully contacting the sulfuric acid flowing from top to bottom in the tower to be dried. Chlorine flows out from the top of the tower to the acid mist collector and enters the chlorine compression system after removing the acid mist. The sulfuric acid with a concentration of about 95% entering the upper part of the 2-in-1 drying tower with packing and sieve plates comes from the high-level acid tank and is cooled by a cooler. The 95% sulfuric acid in this high-level tank comes from the pump acid, periodically replaced by the yeast ring chlorine compressor and Nash pump. The sulfuric acid entering the packing section of the 2-in-1 drying tower with packing and sieve plates comes from the upper sieve plate section and is recycled after cooling by a sulfuric acid circulation pump and a sulfuric acid cooler, with its inlet temperature controlled at around 2 degrees Celsius. When its concentration drops to about 75%, or the tower bottom liquid level reaches a certain height, it is pumped to the wet sulfuric acid storage tank, and then packaged and sold externally by a dilute sulfuric acid pump. The main equipment for chlorine drying is the drying tower. The drying tower is generally filled with acid-resistant packing, such as ceramic rings. The upper part of the tower is the acid inlet. The acid evenly wets the surface of the packing through a distributor and is discharged from the bottom after absorbing moisture in the chlorine. Drying towers are generally divided into the following types. Packed drying tower. The structure of the chlorine packed drying tower is similar to that of the chlorine scrubbing tower. 2-in-1 drying tower with packing and sieve plates, generally composed of a lower packing section and an upper sieve plate section. Bubble cap drying tower. The tower body material of the chlorine bubble cap drying tower is generally rigid PVC or FRP with 5 layers of trays. 2-in-1 drying tower with packing and bubble caps, generally composed of a lower packing section and an upper bubble cap section. In addition, foam towers are also highly efficient gas-liquid contact equipment, widely used in chlorine cooling and drying. A foam drying tower is composed of a cylindrical shell and several trays horizontally, arranged at a certain spacing. The cylinder of the foam tower is equipped with trays, internal and external overflow pipes, liquid receiving trays, etc. The entire tower is equipped with several trays, and a certain proportion of sieve holes are opened on the trays according to the production load and a certain opening rate. The sieve holes can be straight cylindrical openings with the same diameter at the top and bottom, or special-shaped nozzle holes with a small upper aperture and a large lower aperture. At present, Enhanced foam towers are being promoted, which adopt an external overflow and large liquid flow circulation method to ensure that the gas transmission load meets the production needs. Finally, let's look at the acid mist collector. As shown in the figure, it is composed of a cylindrical body, upper and lower end caps, and a filter cartridge. The cylindrical body, upper and lower end caps, and filter cartridge are made of carbon steel. The filter cartridge has an inner glass fiber layer and an outer layer with metal mesh used for both inner and outer layers. The glass fiber layer uses long fiber glass wool impregnated with fluorosilicone oil treatment. Long fiber glass wool has very good water repellent, acid repellent properties, and self-cleaning acid miscibility. The thickness and filling density of the glass fiber filter layer are determined by factors such as gas transmission volume, airflow resistance, and acid mist removal efficiency. In this lesson, we learned about chlorine drying and related drying equipment. See you next time.